Hello, my name is Marco, and in this video I'm going to explain how to solve a machine learning example of the energy and utilities field using Neural Designer. The topic of this example is wind turbines. We are going to use neural networks in order to model the wind turbine's power curve using the wind speed received by the turbines. First, we will download the data file from the link below. If we open it, we will see that it contains information about 48,007 instances, each representing the power generated by the turbine for a certain wind speed. The data file is organized in two columns, wind speed and power generated. Now we can open Neural Designer, where we can see two different project types we can create. In this case, we want to make an approximate prediction of the target variable based on the rest. In order to do that, we will use the approximation project functionality. Once we've created the project, we must import the dataset we just downloaded. Once it is imported, we can see a preview of the data, which gives us the number of columns and rows in our file. In this table, we can check the different variables or features and select the one that is going to be the target variable. In this case, we will choose power. In order to get to know our data, we will perform a brief analysis. First, we want to know how the different variables are distributed, and in order to do that, we can calculate the column distributions. We have different distribution charts for each variable. We can also check how the wind speed impacts on the target variable. We can do this by calculating the input's target correlation. Here we can see that they have a huge correlation. To get some extra information, we can click the scatterplot functionality. There, we can see how there is almost a linear correlation between our variables, only broken for a starting threshold and a saturation threshold. The first one meaning that the turbines need a minimum amount of wind speed to work, and the latter meaning that there is a maximum power the turbines can generate. Now, we've reached the time to start building our model to predict the power generated. We will click in the Neural Network tab, where we can alter the network's architecture settings. As a first guess, we will leave everything by default. Now we can create and visualize our neural network. This diagram means that when we introduce one input or variable into our neural network, it gives back one output. The next step is to train our neural network. That means to search for the weights or parameters that will best fit our data. After the training process, we can see how the error has decreased with each iteration. The most important result is the final selection error. As we chose as metric the normalized squared error, a value of 1 would mean that the network predicts in the mean, and an error value of 0 would mean that it makes a perfect prediction. We can see how good the model is by performing several testing analyses. In approximation problems, the best way to visualize the model's performance is to make a regression analysis. In this chart, we can see, in the x-axis, the real value of the target variable, and in the y-axis, the predicted values. If the model was perfect, the regression line would be a straight line with a slope value of 1 and passing through the coordinates origin. In our case, we can see how, even though the regression is not perfect, all the values fall next to the regression line and we have a good correlation coefficient. Another testing method is visualizing the error's histograms. We can see here the distribution of the error values. This figure shows that most of the error values are closest to 0. If we calculate the error statistics, we will see that everything makes sense, as the mean percentual error is 3%. This means that our model predicts the power generated by the wind turbine with only a 3% error. Finally, we can calculate specific outputs in the model deployment section using the calculate outputs function. Here, we can see our model's target variable's value for a given set of inputs. Another useful functionality of the model deployment section is plotting the directional output, where we can see how the target variable depends on the inputs. It is also possible to write our model's mathematical expression or to export it to different programming languages such as Python or C. Thanks for watching. Hopefully this tutorial helped you make the most of Neural Designer. Don't forget to subscribe if you liked our content and if you want to learn more about machine learning and Neural Designer.